Hello children, welcome to channel Sube. Children, today I am going to discuss question number 1 from the MCQ part of 2022-23 Physics New Syllabus paper. Which one of the following pairs of quantities consists of a vector and a scalar respectively, yeah? Therefore you can't change it. Mass, velocity, power, speed, work, distance, force, potential energy, momentum, torque. So according to the order, it must be vector first, then scalar second. If not, it is wrong. First one, mass, velocity. What is this mass? Is it a vector or a scalar? Mass is a scalar. We can't place it under that topic, vector topic. Mass is a scalar. Velocity is a vector. Therefore, these are not in order. They should change. So therefore, this one is wrong. Why we say mass is a scalar? This one is a scalar. It has only a value, not a direction. It hasn't a direction. We don't consider direction. When we go to buy 1 kilogram of sugar, do we say the direction to the seller? No, we just say give me 1 kilogram of sugar. So therefore we don't consider direction. Therefore it is a scalar, it is not a vector. But regarding velocity, we consider the direction. Especially velocity is used by pilots who control aircrafts. So they must consider the direction. Otherwise they will land somewhere else. Therefore especially the pilots use velocity. We also use velocity, because otherwise we also land somewhere else, not where we were determined to go. So velocity has therefore a direction. Therefore it is a vector. Velocity is a vector. So these are not in order, even though one of these pair is a vector and other is a scalar, but they are not in the order. Therefore it is wrong. So the second one, power and speed. Regarding power, what you can say? Is it a vector or a scalar? Power is the energy used per second, or work done per second. So per second is the time. Time is a scalar, because we don't say direction, 2 hours, 3 hours, just we say that's all. The class will be finished after 2 hours. So we don't say the direction, south, north, like that, vertically, upwards, horizontally, we don't say. We don't even use angles. So that is therefore a scalar. Time is a scalar. And also the energy divided by time, that is power. So energy also is a scalar. Why? Energy we get from batteries. So do we speak about any direction? No, we say battery is full, or we say battery is dead, empty. And we get sunshine, energy from the sun, light energy. We use light energy, heat energy. But no direction is considered. But the light is coming from a certain direction, but light energy has no any direction. If it is energy, we just measure it by joule. So it has no direction. we don't consider direction. However, if sunlight is there, that is enough. And time also is scalar, it is a scalar. So therefore finally power is a scalar, it is not a vector, therefore it is wrong. Both are scalars, here both are scalars. Power is a scalar, speed also a scalar. Why? Speed. So bus drivers say we must increase our speed. Then the helper doesn't ask to which direction. He doesn't ask that because it is not important. Speed is just the running power of the engine. So speed has no direction. Whatever the direction doesn't matter, we have to increase or decrease the speed. So therefore it is a scalar. It doesn't have, we don't care, we don't consider any direction when we use speed. So therefore both are scalars here, therefore it is wrong. Both are scalars here, therefore it is wrong. So this one, work distance. Both are scalars because work also is a scalar. We hire a person to get some work done. Suppose we have to transport some stones from here to here, but after the day we have to pay him. We don't ask to which direction you worked, south or north, west or east. It is not important, we have to pay him. We buy his energy, work per day, so there is work. So we have to pay him. We don't care the direction, so therefore work is a scalar. If we do some work, only the quantity is considered. If someone asks you to do a certain work, he finally might ask, have you finished it? So you have to say yes or no. He doesn't ask to which direction did you do your work. So that is abnormal. So therefore you have to identify, you have to aware that work is a scalar. So you don't have to use any equations. That is your what we call that is your common sense, that is general knowledge. Work is a scalar. And distance also is a scalar. We ask somebody how long is it, far or close? So he might say it is very far. So we don't ask distance because various directions you have to go, but far means the length of this road is the road is longer, far. So therefore that way you can identify, you can understand that distance, if you say distance, it is a scalar, it has no direction. So therefore both are here scalars. Both are here scalars. Work and distance both are scalars, not vectors, therefore wrong. And now the fourth one, force and potential energy. So what do you think about force? Is it a vector or a scalar? You have to think like this. Don't use equations. Imagine that there is a banana tree. So it has a bunch of banana, even the fruit. So now what we have to do, we have to give this tree a support, otherwise a small wind even can blow down the tree. So therefore we have to prop up the tree. So if we use the prop like this, is it correct? No, it is wrong. The people will laugh at us. So therefore if you do it properly, you have to fix the prop like this. You have to prop up like this the tree. So then what we do is by propping up it like this, giving a certain force towards the tree so that it will be protected by winds. So like that we have to consider the direction. When we are giving a force, we have to consider the direction, and also imagine that there is a inclined road. So there is a vehicle, we have parked it, so handbrakes are not sure, so therefore we place a stone here at the tire. So if we place this stone like this, so it is correct. Have you seen small children do place the stone like this? So that is wrong, because we don't, so the children don't know about to consider the direction, so we laugh at that. So therefore that means when we are giving a force, always we have to consider the direction. We have to consider the direction. If we consider the direction, then we say it is a vector. So therefore this one is correct. Force is at the vector side now, it is correct. And potential energy, I explained previously when we were talking about this power. Energy is a scalar, it is not a vector. All the energies are scalars, because energy, imagine, you have to image, you have to think about, you have to observe properly what is energy. So we take energy from batteries, and heat energy, then light energy, chemical energy, mechanical energy. There are a lot of there are 5 energies. So when we use energy, do we say the direction? Do we consider the direction from north to south to west? Like that we don't say. Energy, only the quantity. We pay light bills, electricity, we pay for electricity bills, we pay bills. Do they ask the electricity board, do they ask to what direction you used our electricity? No, they don't ask. We have to just pay according to the units that we have used. So therefore energy is not a vector. They not mean everybody don't consider the direction. It is only a, it has only a magnitude, so it is a scalar. So potential energy is definitely a scalar therefore. So now this one is correct because it is at the scalar side, so it is a scalar. This one is at the vector side, so it is a vector. So therefore this one is correct, not that mark, correct. So the fifth one, momentum. What is momentum? So now let's go to this fifth one, momentum, and torque. So what is, children, momentum? Momentum means momentum is the ability to break through an obstacle. If you say whoa, then it means momentum. What we get from cannons is momentum. Cannons, you know, from cannons we get momentum, because the bullet must be, the mass of the bullet must be greater, higher, and also speed must be higher. Then only we can do a bigger damage. Then also we get momentum from backhoes and bulldozers. The greater the mass of the bullet, the greater the momentum, and the higher the speed, the higher the momentum. More of both is better. So the equation for momentum is, you know, m times v. Therefore at least if one quantity is higher, then the totally the momentum is higher. So it is a vector because the velocity has a direction. Since the velocity has a direction, totally the mv term has a direction. And also, without using equations, we can consider if we are going to do a damage by using momentum, that means by using this type of cannon, we should consider the direction, otherwise we are going to damage ourselves. So therefore it is a vector. We call momentum is a vector because we have to consider the direction. So therefore it is at the correct side. So momentum is at the vector side. So torque also is a vector. Torque. What is torque? That is the physical quantity that we use to rotate something. To rotate something this way or that way. So there are two directions at least. When we lose a nut, when we lose a bolt from a nut, so we use torque. If we don't know the direction, sometimes we tighten it other than losing it. So that is because we don't know the direction. Not only two directions are there for torque. If you imagine a side mirror, so there is a ball like this. So there is a socket like this, and the side mirror is mounted like this. So you can rotate the side mirror in various directions, not only two. So we give torque in various directions to a side mirror when we adjust it. So therefore it is a vector. So these both are vectors. Therefore this one is wrong. So children, now the answer is fourth one. Let us check the question number 1. Fourth one, yes, fourth one is the answer. So children, I think you can understand. This one is not a big issue, this first question. So children, I think you are happy. If you are happy, you have to subscribe my channel. But if you already have subscribed, don't press that button again, then it will be cancelled. If you haven't subscribed yet, then only you have to subscribe. So I am helping you, you can help me that way. And also you can press that bell icon, and also you can share my link among your friends. And also press that thumb up icon, give me a like. Then see you tomorrow children. And also I have to thank all the students who subscribed my channel already, and also who watch my videos. Thank you. Then children, see you tomorrow at 6 o'clock in the evening. Goodbye.